In this video lecture, we're going to introduce isomers. So the definition of isomers, we have compounds that have the same formula but different structures. That means they have the same chemical formula, so the same number of each atoms, but somehow the arrangement of the atoms are different. In this section, we're going to look specifically at structural isomers, coordination isomers, and linkage isomers. So a structural isomer, that means the atoms have different connectivities. That essentially means we have different bonds. So maybe in one structure we have an iron atom bonded to a chloro ligand, and in another structure we have an iron atom bonded to a bromo ligand. That would be an example, what I just discussed, of a coordination isomer. So a coordination isomer, the ligand and the counter ion exchange places. So in order to have coordination isomers, we need a ligand and a counter ion that can change places. So when can that happen? That means you must have an anionic ligand and a counter anion, and they're going to swap. So they swap places. The reason you need a counter anion, because if you had a counter cation, remember, we never have ligands that have positive charges. The other type of isomer we're going to cover and discuss today are linkage isomers. A linkage isomer, you need a ligand with more than one possible donor atom. So a ligand with more than one possible donor atom. So let's go ahead and look at some examples on the next slide. So in this image, we see what's called a nitroisomer and a nitridoisomer. So remember our ligand list, nitro is NO2 minus as a ligand with N as the donor atom. Nitrido, NO2 minus, but we have O as the donor atom. And that's what we see here. So in this image, we have a metal center. I see this is an octahedral geometry with a coordination number of 6. It looks like I have 5 ammonia or amine ligands, right? N with 3 H's connected. And then here I see this is nitro because I have the N that is the donor atom donating the 2 electrons to make that ligand to metal bond with oxygens on either side, giving us the chemical formula NO2 minus. Over here, same structure, but I can see that O is the donor atom donating those 2 bonds to that metal center. And you can see with the nitroisomer, that compound is more of a light orange or yellow color, and the nitrido isomer, we have more of a darker orange or a rust type color. So the same chemical formula, the same metal center, 5 amine ligands for each, but here we have NO2 where N is the donor atom, and here we have NO2 as a ligand where O is the donor atom. So these are examples of specifically our linkage isomers. We have a ligand with more than one possible donor atom. So in the linkage isomer, I have the different bond between the metal center and that same ligand. It's a different bond between the metal center and the donor atom on the ligand. Let's look at one more example. So another example of a linkage isomer. If I give you the chemical formula, Na2PTSCNBr3. In this example, I know I can have a possible linkage isomer because I recognize the ligand SCN-. I know I name this thiocyanato if S is the donor atom, or isothiocyaнаto if I have N as the donor atom. So let's draw both of these linkage isomers. The first thing we need to figure out is the coordination number. I know I have a coordination number of 4 because I have my 1 SCN- ligand. I also have 3 bromo ligands. I know if I have a coordination number of 4, I could either have a tetrahedral or a square planar geometry. To figure out which one, I look at the d electron count for the metal center. To do that, we need to identify the charge of platinum. Well, I know that each bromo is -1. I have 3 of them, so that's -3. My SCN- ligand has a charge of -1. Each sodium counterion is +1, which gives us +2. So I have a total of -4 and +2. So the platinum must be +2 for its oxidation state. So platinum 2+. If I look at my periodic table, I start from the very far side. I cross all the way over to 10 - 2 gives me a D8 metal. And then I know this is indeed square planar. So let's go ahead and draw that. I'll have platinum in the center, 4 ligands. I know the overall complex is a 2- charge because I was given 2 sodium counter cations. I'm going to add my 3 bromos first. And then I'm going to add my thiocyanato, which is S donor. So I have my S as the donor atom, and then CN. So we would name this, a good time to review nomenclature, sodium, separate word, tri-bromo, and then S donor is our thiocyanato. And this is a complex anion, so we will name it platinate 2. Again, ending in 8 because this is a complex anion, so we end in 8. So that would be one linkage isomer. The other linkage isomer, I will draw it the exact same way. And I'm going to change my donor atom from S to N. So now I have NCS. And so this really emphasizes the importance of showing which atom is the donor atom, because we end up with a different complex and a brand new name. So to name this complex, I have sodium, right, the counter ion, or the cation first, which happens to be our counter ion, and then our ligands in alphabetical order. So I have tribromo, and this time my N donor atom, which is isothiocyanate. And then platinate 2. So 2 different words, sodium, tribromo, isothiocyanate, platinate 2. And we can see with these 2 examples that we have the same chemical formula, right? Our chemical formula is listed right here, but I have a different bond. In this first isomer, I have a bond between the platinum and the sulfur of SCN-. In the second isomer, I have a bond between the platinum and the nitrogen of this isomer. And I can also see I have different names based on the different donor atom. The next example we're going to look at, or the next type of isomer, so still looking at structural isomers, are coordination. And as a reminder, we have a ligand and a counter ion swap places. So an example of this, ZnCl H2O2 NH3Br. The reason I know I can have a coordination isomer is because I recognize a counter anion and a ligand with a negative charge. So this will be my first structure to draw. So let's figure out my coordination number. So I know my coordination number in this case is 4, because I recognize 1 chloroligand, aqua, and I've got 2 of them, and amine. So my shape is either square planar or tetrahedral. I have to figure out the d electron count of my metal center, which is zinc. I know my bromide anion is -1. Ammonia and aqua have a charge of 0. Chloro is -1, so zinc is +2. Looking at my zinc 2+ oxidation state on the periodic table, start at the far left, count all the way over to zinc, subtract 2, we end up with the D10 for zinc 2+. So my shape is going to be tetrahedral. I will draw my zinc in the center, line, line, wedge, dash. Really important to have this drawn in 3D. Square brackets, I have a bromide counter ion, so my metal complex has a +1 charge. I'm going to add a chloro, a water. Remember, oxygen is my donor atom, so O needs to be touching that bond. Another one, O is my donor atom, H2. So I wrote it backwards because O is the donor atom. And then lastly, amine, N is my donor atom, H3. And we could name this. So we're going to name the ligands in alphabetical order, aqua, amine. So amine comes first, AMMINE. Then aqua, I've got 2 of them, diaqua. And lastly, my chloro. And then zinc 2. It ends just as zinc because it's a complex cation. Right? This is a positive charge. And then I name the anion, which is bromide. Let's go ahead and draw the other isomer in this case. So the other isomer for this structure, I'm going to swap my chloro ligand and make it an anion. So the other isomer would be zinc, Br, H2O2, NH3, and now Cl. So you can see how I swapped the counter ion and the anion ligand. To draw this structure, I will have zinc in the center. Still my tetrahedral arrangement because I haven't changed anything. Plus charge my Cl minus, my chloride counter ion. And now I'm going to have bromide, and everything else will stay the same. And we would name this amine diaqua bromo zinc 2 chloride. Again, naming the cation before the anion. We're naming our ligands in alphabetical order, right? Not counting the prefixes. So this was a lesson looking specifically at structural isomers. We looked at the difference between a coordination isomer, where you swap the anion, a negative ligand, and a counter anion. And we looked at a linkage isomer, where we have a ligand that can have more than one possible donor atom. And if you look at our ligand list, you'll notice there's only a few ligands that can participate as a linkage isomer. And you can tell them because on the ligand sheet, you have more than one possible donor atom. So that would be cyanide, cyanate. So for the linkage isomers, the ligands that we need that can participate in linkage isomers, cyanide, Cn minus, cyanate, OCN minus, thiocyanate, SCN minus, and nitrite, NO2 minus. This was also hopefully a good review of nomenclature.